Good morning, ma'am. Hello, good morning, everyone. Hema madam here.
Good morning, madam.
Good
Morning,
morning.
ma'am.
I think madam
Good
will
morning.
join by 9:30. Good morning.
Good morning,
Good
ma'am.
morning, ma'am.
Yeah, madam may join by 9:30, I think. Anything to discuss with me?
Yes, ma'am.
Yes, tell.
Ma'am, last time we had gone to the college na, so that time that Hasnat college sir was there. So he like told us for MEVL11,
Hmm.
our practical exams will be held on 21st of May. So I just wanted to confirm that whether it is going to be the case, because now new schedule has come na, and all the classes until 26th of May. So we have bit of a doubt there. So like how the schedule is going to be.
No, if it is fixed on 21st, when you come, that is also held there only. We'll
Okay,
make
so
the group. Madam has joined now. Good morning, madam. Madam will explain. According to madam's instruction, you can go, madam. Okay?
Good
Even
morning, ma'am.
this
One
schedule
small
also.
thing.
Yeah.
One small thing, ma'am. Actually, whoever is registered on a July 21st are eligible for the 12 and 13, right?
Yeah. It is only for them.
Okay, right. Thank you, ma'am.
Good morning, ma'am.
Okay, your exams also, you are a small batch for the first year, and for you, okay, in batches, they will conduct the exam also because you will have to complete all the three. And so many of them are due for December 22 exam also. So we should be able to complete all the three for your batch. So that time they will plan like that, okay? For,
Because I have not received the emails, ma'am, which have
for
come for recent 12 and 13th. Some of them have received emails, some are not received. That's why I'm asking.
See, we don't do like that. Whatever the data we have with us, we will send to all. It is a group. The computer section will, our admission section, when we send the schedule to them, they will send to all. If any problem with your email ID, write to RC Bangalore. Because whatever the registered email IDs are there in the Samarth portal, they will send to all. We don't select people like that. Batch wise, they will send. We will mention for this batch you have to send. So we will send to all. So you just check and
Okay,
send
ma'am.
the mail. Send the mail. We will check any mail problem. We don't know.
Okay.
okay, ma'am,
You
one
belong
more
to which
query.
batch?
12 and 13th, ma'am.
No. Which batch admission you belong to?
July 21st.
July 21.
Yeah.
Okay.
But I have paid the amount of next registration little late.
That's what you are not received, I think. Whoever re-registered for the second year in January 22 and July 22 have received the mails. They are due for this. That's
Okay,
what.
so ma'am, who have
July I
You
have
have
registered
paid, ma'am.
joined maybe in
July
January,
to
little late, matlab, whatever is shown in your re-registration is maybe January 23 you have started.
no July 20. Okay, I will send an email, ma'am. Why you have to
That's
disturb
what
all
you have
about
not
it?
received. Otherwise, for all of them, whoever re-registered for the second year, it is not.
I will with the
For the
screenshots.
second
I will
year,
send a mail, ma'am.
these two are the second year practicals. Only for the second year students who have joined in July 22 and January 22. Only for these two batches, these are meant. So you
Okay,
have
ma'am.
not received. You just check your online details. If it is mentioned as January 23, it will be conducted later for you. Okay. Okay. Then madam is there. Okay. Discuss with madam also, and please check your registration details. If you have enrolled for the second year in January 22 and July 22, you are eligible to attend this two classes and the exam this time. Okay. Okay, madam.
Ma'am,
Madam,
Jan
thank you.
21st only registered, but I'll send a thorough email, ma'am. Thank you. Yeah.
Yes, yes, you send, sir. Any email ID details and all, they will check.
Excuse me, ma'am.
Yeah.
One query. Actually, this MEVL 12 is for the first year only, right? Not for the second year.
Whatever it is, your batch is okay eligible for all the three.
No, no, I am July 22 batch actually. Hello, ma'am.
Okay. See,
Ma'am, we are in
there
first
is
year
one batch
currently.
pending for all the three. That's what we have made a small group and doing it. For July 22 batch, once again we will conduct along with January batch. Okay, this
Okay.
is only for those batch we have sent. Whoever was due for December 22, there are 19 students pending for that. Along with them, July 22, whoever re-registered, for them also we have sent. Okay.
Oh,
For the
okay.
second year only who have re-registered. Then we
Okay.
will conduct once again. Okay.
Okay, ma'am. Okay.
Don't worry.
Okay, ma'am. Thank you.
If the batch is very big, they will not be able to do the exam, classes, everything all together. So we have selected only two groups now to
Okay, ma'am.
complete. Okay. Yeah.
Okay, ma'am. Thank you.
Good morning, ma'am. Sudishna here.
Yeah.
Ma'am, can you just guide us through how the exams will happen and where? Will it be in the
That
same
and all, the
college?
center will explain, madam. This
Okay, okay. And the
madam will
papers and
let
all
you.
will come from IGNO or they will prepare,
No,
ma'am?
no, they will tell you, madam. That is the internal
Okay.
practical examination. Madam will explain.
Sure, sure. Thank you.
Okay.
Ma'am,
Yeah.
ma'am, the exam is also for first year students or it is only for second year students?
Madam, all three that by your batch has to complete, madam. Whoever joined for the first year in January 21 and July 21, those two batches have to complete all the three.
Okay.
Second year
All right.
also, who has completed in December 22, second year theory, everything they have completed. And some of you are going to complete in June 23 exam, every theory papers eligible to complete. For them, all the three exams will be held.
Okay.
Okay. The other
Actually,
batch, new batch is there,
I'm
July 22 fresh batch. For them, we will
huh.
conduct later.
Okay, so this month exam will not be for the first year. I'm from first year actually. That's why I'm asking.
First year,
I
how did you join this meeting then?
actually it came on the group, so we did not understand because
You
many
are
of
not
them
in
have
the
not
group,
used.
no? You are not in this small group is there only for January 21 and July 21.
Okay.
This is the
All right.
confusion. I
So
have
I will.
written in the mail very correctly that it is for this batch, it is for this batch. You just see that. Okay? No
All
confusion.
right.
Because
So
if you
we'll
are not
exit.
eligible and
Okay.
you are attending the exam, your result will not be declared. That again I will mention while sending for the examination. Okay. So if
All
you are
right,
not
ma'am.
eligible for this exam, it is not for July 22 batch. I have already
Okay.
clearly mentioned that is a very big batch. We will conduct later also for them practical counseling. We have to complete for these two small batches. That's what we have called them for the practical now. It is not for July 22 batch. Unnecessarily
Ma'am,
don't join the batch. July 22 first year fresh batch, don't join the batch. This
Okay,
practical.
ma'am,
ma'am.
this will be
Okay.
this problem will end if you give me the list of that 19 people and the other batch what you are considering. Because mine is Jan 21 registration.
But when you re-registered is the matter, madam. I don't have the list. The admission section, the computer section has the list. I will send only the schedule to them mentioning that whoever has re-registered for the second year in Jan 22 and July 22. Re-registration matters now. I am not concerned about this first year joining and all. Some people who have joined in first year, they have not joined for the second year in January 22. So many of them. Then again, they have come in July. Some of them have not joined for the second year in July 22. They have joined in January 23. So information will not go to them. Please remember, whoever has re-registered, you go to your online registration details and check that second year registration when it is done. If it is done in January 22, second year, July 22, second year, these practicals are meant only for them. Okay, you just check your registration details and then you can join.
Excuse me, ma'am. Good morning.
Yeah,
Actually, 15th is the last date for assignments, ma'am. Shall we go and hand over hard copies to the college? Will it be open on Sunday, ma'am? I mean tomorrow.
you can check with madam. Shapaka sir may be able to tell if they are open. You can discuss
Who,
with them.
ma'am?
Whenever you come for the face-to-face counseling, that time you can. No problem.
Oh,
Till
okay,
May
ma'am.
end,
Thank you, ma'am.
whenever you come for the practical classes, no physical practical
Okay.
classes. Maybe next week we can call. This
Okay,
online
ma'am.
again, you all will be confused. Once again, I will send the mail. I have
Okay, ma'am.
clearly, yeah, told that only for the second year, January 22 and July 22, because this is a very small group. We wanted to complete all the three practicals only for them. If unnecessarily all the other people are joining, taking the link from some other people, it will create confusion now. Okay. So please see your registration details. If you have joined for the second year in January 22 and July 22, you are eligible to attend this practicals. That's all. You go to registration details center. Assignment submission. Whenever you come to the center, you submit. Don't stick to this 15th. Okay, no problem.
Okay, ma'am.
Till the
Thank you,
end of
ma'am.
May, till the end of May, whenever you come to the center, bring your assignments. Okay, and synopsis also, project, whatever it is. Okay, okay.
Thank you,
Then
ma'am. Thank you very
we
much.
will discuss later also another day. Madam is there. Sabha madam can continue now. Okay. Madam, you can continue. Thank you, ma'am.
Ma'am, you are not audible.
Madam, you are not audible.
Okay. Now, am I audible now?
Yes, ma'am. Now you are
Yes,
audible.
ma'am.
Yes, ma'am.
A very good morning to all of you.
Good
Good
morning.
morning.
Okay, not required. So I just want to tell you that last practicals what we did in college and in the online class that were for MEVL 11, you had to maintain a different separate record book, separate observation book for the calculations, and we really had a very good experience last classes. Okay, same way for MEVL 12, you will be having a separate record, but observation book can be continued in the same. Okay, you can continue the experiments in the same observation. Do not misplace the observation books. Record book should be different. So there are 17 experiments here. We'll try and finish at least 5 experiments today. Okay, in the morning session. 5 experiments in the morning session. Out of those 5 experiments, experiment number 4 and 5 are the same experiments what we did in MEPL 11. That is biological oxygen demand. Okay, so they are the same experiment. Especially experiment number 4 is the exact copy of the previous experiment what we did here. You people also took the readings and went. Okay, and experiment number 5 is like the same experiment, but in calculations you will have certain things to be adjusted. All right, but the procedure is the same for both the experiments, that is biological chemical demand and oxygen demand. Biological oxygen demand and biochemical oxygen demand. These are the two experiments of your MEVL 12, that is 4 and 5. They are exactly the same experiments what we did in the last class. Where experiment number 4, I'm repeating again, is the same using the same reagents. Okay, well, some of you made the reagent and the reagent was not good, so we had to re-prepare the reagent and then we got good readings. Okay, sir, I'm sorry, I don't remember the sir's name, but sir beautifully performed the experiment. Okay, likewise, the same experiment is experiment number 4 of this particular practical also. Experiment number 5 is also the same, but calculations are slightly different. Okay, in that way, we'll be completing 5 experiments in the morning section. We'll try and do some more experiments in the afternoon session. All right. So we are starting with the first experiment. The name of the first experiment is determination of conductivity, electrical conductivity of water sample. We are determining electrical conductivity of water sample. Almost all 17 experiments of this particular practical are all with respect to water and soil only. All right. So these are very easy experiments also. Okay, we require some apparatus, and with the help of apparatus, you will be getting the conductivity. You don't have to go to any field work like how you did last class. All right, so we are starting the experiment. Please write the heading MEVL 12. MEVL 12 practical number 1, experiment 1, determination of electrical conductivity of water sample. Like how we did in the last online classes and in our practical classes. Likewise, you will be copying down everything, whatever is told in the class. And please be sincere with your work. So that next time when you come here for calculation, some of you didn't do it, it was very difficult for you to calculate here. Okay? Done? Shall we start? So since we are asking you to determine
Yes, ma'am.
electrical conductivity, we should first know what exactly is electrical conductivity. What is conductivity? Please write down what exactly is conductivity. Conductivity is the measure. Conductivity is the measure of the ability. Is the measure of the ability of the aqueous solution. It is the measure of the ability of aqueous solution to carry electrical current. I am very much sure you must have not understood the statement. We are measuring the ability of aqueous solution. Conductivity on the whole is defined as a measurement of aqueous solution which can carry electric current. How much of electric current can that particular aqueous solution carry? That is what we are measuring. And that aqueous solution is nothing but the water sample. Clear? So here the procedure is very, very simple. You need to just understand. I am repeating again. Conductivity is nothing but the measurement to measure how much of electric current can the aqueous solution carry. Now, what exactly is an aqueous solution? You must have come across these two terminologies. One is aqueous solution, the other is molten solution. Okay? Aqueous solution is when you are dissolving something in water. When water is used there, that particular solution is called as aqueous solution. Now, your water sample is completely a liquid sample. Henceforth, we are determining the conductivity of that particular water sample. How much of the current can that particular water sample carry? That is what we are determining. Now, what exactly is the other term called as molten solution? Molten solution means you are not mixing any amount of water in it, but you are melting that solid substance. Now, to give you a clear picture of it, if I have to use an electrolyte, what is the meaning of electrolyte? Electrolyte is that particular chemical substance that will give you two different ions on ionization, on dissociation. You must have come across this type of chemical reaction called as decomposition reaction or dissociation reaction. What happens there? You will be having one reactant present. With the help of heat, light, or any energy, electricity, we dissociate that particular compound. For example, NaCl. When NaCl is in solid state, NaCl cannot dissociate. It will not produce any ions in it. For an electrolyte to function, we require the production of ions. NaCl, when present in solid state, will not produce any ions. Henceforth, we have to convert that solid NaCl either in aqueous solution or in molten state. Okay, so what is exactly aqueous solution? Aqueous solution means you are dissolving the NaCl in water. So we are using water here. So wherever you are using water, that particular solution becomes aqueous. What is molten solution? You are not dissolving, instead you are melting. So this particular information is given to you to give a clear picture of two different terminologies. What is exactly aqueous solution? What is molten solution? Here aqueous solution, what we are using, is nothing but water. Water is the only aqueous solution we are using, and we are determining the conductivity of water. How much of electric current can that water produce? Clear? Okay. So can this happen in an ionized, completely dissolved, pure water? Okay, can this conductivity take place in pure water? That will be a doubt to many students. Pure water in the sense, your distilled water. Conductivity cannot be determined in distilled water. Okay, please make a note of it. Conductivity cannot be determined in distilled water because for conductivity to happen, you require ions. And distilled water do not produce. It is an unionized water. It is not giving any ions in it. So conductivity cannot happen in distilled water. Rather, it is taking place in any other water sample. Clear, students? Please write the definition and make a note of it that conductivity will not happen in distilled water. It is happening only in normal water samples. Please make a note and let me know if it is finished.
Finish, ma'am.
Oh, if it is done, we are going forward. How are you measuring conductivity? How are we measuring conductivity? Measurement of conductivity, please write down. Measurement of conductivity. Conductivity can be measured in two ways. One is called as microsiemens per centimeter or micromoles per centimeter. The other is millimoles per centimeter. Okay, micromoles per centimeter or millimoles per centimeter. Micromoles can be given written as mu moles. Okay, when we are writing it as in the form of SI unit, you have to write this. So conductivity can be measured in two ways. One is micromole centimeter, the other is millimole centimeter. Okay, is it done?
Can you repeat that?
Measurements of conductivity can be conducted in two ways. Measurements of conductivity can be conducted in two ways. One is micromole centimeter. The other is millimole centimeter. Two ways of conductivity, measuring conductivity. One is micromoles centimeter per centimeter and millimoles per centimeter. All right. So what exactly is required for this conductivity? For conductivity to happen, you require apparatus. Okay. We require some reagents. And we have to prepare reagents. For the preparation of reagents, you require chemicals. What chemicals are needed? Okay, all those things will be done. First one, which instrument are we using? Write down apparatus, instrument, conductivity meter. We'll be using the instrument called as conductivity meter. Okay, in apparatus requirements, you write instrument used to conduct conductivity of the water sample is conductivity meter. Now that particular conductivity meter will be having three knobs. Okay, we have one conductivity meter, and that particular conductivity meter will be a digital one, and it will be having three knobs. Okay, if you don't know, three knobs will be present. In those three knobs, the first knob is called as calibration knob. Okay, you please write it CA. For your information, this is because most of you must have not seen it. So there will be a digital conductivity meter. Your reading will be shown. Okay, reading will be written here. Digital reading will be shown. Three knobs will be present. First knob is called as calibration knob. The second knob will give you cell constant. Cell constant. And the third knob is giving you range. Three knobs are there: calibration knob, cell constant, and range. Then we'll be having the positive and negative terminals to which the cell will be connected. Okay? Cell will be connected to those positive and negative terminals. It is not the cell. And this cell is connected to positive and negative terminals. We will also require a range of temperature reading apparatus. Okay, temperature reading apparatus is also a digital one. And we require some amount of KCl solution, that is potassium chloride, in a beaker. In a beaker, we require KCl solution. So these are the three things we want. One is conductivity meter, the other is temperature reading meter, and then we want KCl solution in one beaker. In another beaker, we want your water sample. Okay, two beakers we are using. One is your water sample, the other is your conductivity meter. Sorry, KCl solution. So please draw them, because this is a theory class. When you come here, you should not go blank with what exactly it is. Okay, so last time a little of that happened. We have to avoid that when you are visiting college again for practicals. Okay, we'll be giving you one temperature reading meter, one conductivity meter, two beakers will be given. One is your KCl beaker, the other is your water sample. So these many things are used in this particular experiment. Now, what are we doing here? Did you all draw this, students?
Yes, ma'am.
Yes,
Okay, in physics, how you draw rough circuit diagrams. Please, whatever I am drawing on the board, whatever I'm asking you to do, please put it in your observation book, because when you come here, the moment you see the apparatus, you get to know just this. All right, now, when you come for exam especially, okay? So these many things we are using. Now, what exactly are we doing? First, your conductivity meter should be preheated. So we will switch on the conductivity meter. We are switching on the conductivity meter. Write the procedure first. First point in the procedure, conductivity meter is switched on for preheating process or warming process. Please mention the first point. Conductivity meter is switched on for preheating or warming process. After you are heating the conductivity meter, we are connecting this conductivity cell to the positive and negative terminals present in your conductivity meter. So we have a conductivity cell present, which is given to you separately. We are inserting those circuit, we are connecting the cell to the positive and negative terminals present in your conductivity meters. The second point is you are inserting the cell to the conductivity meter. After you insert the cell on this particular cell, please look into the board. Okay, the moment you insert on this particular cell, there will be a reading given by the manufacturer. every conductivity cell will be prescribed by a particular reading given by the manufacturer, whoever is manufactured that, which means that is the average range of that particular cell. Clear? So every conductivity cell will be having one particular range reading, which is given by the manufacturer. That will be the capacity of it, or that will be the range of that particular cell. So the moment you insert here, you will see a reading as a label on the conductivity cell. Okay. So the third point, there will be a manufacturer given conductivity cell reading. There will be a manufacturer given conductivity cell reading specified. Okay. For example, if my cell is specified by 0.960, T means it is the reading of conductivity cell. So this particular cell, what I am inserting into my conductivity meter has a reading, has a conductivity constant that is 0.960. Conductivity constant reading given by the manufacturer, that is 0.960. This is the constant reading given to me. So when I am inserting it into my terminals, or before inserting also, you can see the label, and this particular reading will be prescribed to you. You have to note down this reading. Please note down this reading because it is very, very important for you for calculations. All right. So since you are not here for the practical, you take down this reading only in your examination also. That is K is equal to 0.960.
Ma'am, could you repeat it?
K is equal to 0.960 is the cell reading, conductivity constant cell reading. Okay. So I am repeating the procedure again. We have taken the conductivity meter. It has got three different knobs. One is the calibration, cell content, cell constant, and range. We have a digital reading here. We have positive and negative terminal. We have a switch. Here, what are we doing? We are having a conductivity cell. We are inserting the cell into the conductivity meter. Okay, and then we'll note down the reading given on it as a label. That is K is equal to 0.960. So here we have done. Now this particular reading should be adjusted in the calibration, which means this particular reading 0.960 has to be shown in your digital reading. So to be seen in your digital reading, you are adjusting your calibration knob. Okay. Next point, please write down 0.960 reading has to be adjusted in the calibration knob for digital range. Over. You after taking the reading of the cell, you have
Can
to,
you repeat once again?
yeah. So this reading has to be adjusted in your calibration knob, which means you will turn the knob to adjust this reading. Until you get this reading, you are adjusting here. So where will this reading display? This will be displayed on the digital here. Here. So until you get this particular reading here, you are adjusting your calibration knob. That's all.
Okay, ma'am.
Okay. After this, what we are doing is we have to prepare our KCL solution. Okay. Same readings you take for KCL preparation also, students, whatever I am giving you. All right. So after you are adjusting here, go for the preparation. Write down preparation of KCL solution. So for the preparation of KCl solution, you will be weighing 0.5232 grams, 0.5232 grams of KCl, that is potassium chloride, and you will dissolve in 1 liter of water, distilled water, definitely. Okay, so you will take 0.5232 grams of KCl, you will weigh it in your weighing machine, and then you will dissolve it in 1 liter of water. Now, why are we taking this particular grams? Because 0.5232 grams will give you 1000 microsiemens or millimoles, the measurements what we wrote. Okay, because this particular range is equal to 1000 millimoles per centimeter. 1 microsiemens is 1000 millimoles per centimeter. 1000 millimoles per centimeter. So this is the quantity required for the preparation of your KCl solution. Okay, done?
Yes, ma'am.
Okay. Now, after preparing this in your beaker, okay, what you have to do is this particular KCl solution, what you have prepared here, that is what is taken into this KCl beaker. I showed you KCl beaker in the beginning. So it is the same KCl what you have taken. What you prepared, that same KCl is taken in this beaker. All right. So you will take the same KCl and then we'll place this KCl solution. We'll place this KCl solution and we'll dip our conductivity cell into the KCl solution. Okay. So that KCl solution is placed here and this conductivity cell is dipped inside KCl solution. Okay, fourth point or fifth point, whatever the point is, after the preparation of KCl solution, you are checking the conductivity cell constant of KCl solution. So you will dip the cell into KCl solution. When we dip the cell into KCl solution, probably we'll get a reading as 1.003 millimoles per centimeter. Okay, after dipping it into the KCl solution, we'll get 1.003 millimoles per centimeter. This reading will be given to you by the cell. Okay, when you dip here, you will see a digital reading of this particular number. When this particular number is seen, it is nothing but approximately 1. Approximately 1.
Ma'am, please repeat the value, ma'am.
See, when I prepare 0.5323 grams of KCl solution in 1 liter of water, okay, which is equal to 1000 millimoles of centimeter, okay, I'll take that in my beaker, one small beaker of 100 ml, I'll take that water in my beaker, sorry, KCl solution in my beaker, and then I will check the conductivity of KCl solution. When I check the conductivity, if you're taking this particular amount, you will definitely get this reading. If you take 0.5232 grams of KCl, you will definitely get 1.003 millimoles centimeter. This is a definite reading. So this reading is given on the digital. Okay, and then what happens? 1.003 millimoles is nothing but your approximately 1, which means your KCl solution is perfect. Okay. Done till here? Now what we'll do is we'll remove KCl solution and then we'll place our water sample. We'll remove KCl solution and then, which means you are cleaning your electrodes. Now why is that there is a need to dip into KCl solution? This question nobody asked. Okay, the headache is telling you have to determine the conductivity of water sample. But why are you dipping into KCl solution? KCl is neither a salt, neither an acid nor a base. So how is it producing ions? Nobody raised. Somebody's raised the hand, Anushka.
Ma'am, I think it is for taking the reference point for every experiment. We take
Okay,
a
very good.
reference
So if you
point.
have understood, well and good. But if you have not understood, okay, it's to clear your electrodes, take a reference reading of it. That's all. And then after which, what we are doing is we are placing our water sample. Okay, we place our water sample. Whatever water sample you have collected, you are placing the water sample, and then you will again put your conductivity cell. When we are putting our conductivity cell, if the reading goes beyond 31, then you have to adjust your range here. If the reading is going beyond 31, you have to adjust your range. So on the range we'll be having 2 to 20 to 200. Okay, these three numbers will be given 2, 20 and 200. So you should adjust in the way that it should be between your 2 and 20. That is your range. Okay, that range only your water should be. So it should be between your 2 and 20. This kind of adjustment you should do with the range. With cell constant, you have calibrated 0.960. Okay, and then you check the conductivity of KCl. It was 1, well and good. Then, when you are inserting a cell constant here in the water, if the reading is going beyond 31, what you have to do is take the range, adjust the range between 2 to 21. Okay, this range should happen. 2 to 21 adjustment should happen. When you do 2 to 21, your range will come across 0.2 to 1. 0.2 to 1. Okay, this range of water, it should not go beyond 30. If it is going beyond 30, see to it you adjust between 22 to 20, because it is just a normal water. It can be a tap water which you have collected. If it is a lake water, then we have to see the readings. But we are doing with normal tap water. So since it is done with normal tap water, I am adjusting my reading between 2 and 21. So the digital reading will go 0.221. 0.221. This is the conductivity of your water sample. And what is the unit? Again, millimoles per centimeter. Millimoles per centimeter. This is the reading. After you get this particular reading, take out the conductivity cell and insert your temperature unit. Now is it clear? Okay. So after you get the reading of your conductivity constant, take out the cell and insert your temperature. When you insert your temperature, the appropriate temperature should be 25 degrees Celsius. The appropriate temperature should be 25 degrees Celsius. If in case the temperature is not 25 degrees Celsius, you have to adjust, take a range. There is a chart for it. Okay. Right now, I am not providing any chart of like that because I have already taken the reading. So we'll take an appropriate, a middle reading. If it is not 22, 25, when I measured it was not 25, it was 23. So between 21 and 23, I took a reading. Okay, calibrated reading chart is there. With that reading, 105 was the calibrated reading. Okay, so between 21 and 25, what we got 23, 23 is calibrated reading is 105. All right. So what we did is I've taken the calibrated reading. Otherwise, the temperature, the moment you dip the temperature, plug into your water, it should show 25 degrees Celsius. Mine was not showing 25 degrees Celsius. Instead, it was showing 22 degrees, 22 point something. So I've taken a calibrated of 23 and then I've taken a particular reading for it. All right. So likewise, one trial is over. We have to go for concordant values. So one trial of this is done. Again, the same thing you are repeating for second trial. You are cleaning your electrode, that is your conductivity cell. You are dipping in your KCl solution. You are taking the reading again. Okay. So if you get a varied reading, a different reading, you will do a third trial. If you are getting a proper reading, then 2 trials are only enough. So usually we tabulate for 3 readings. Same procedure is done. 3 readings we are tabulating. So after taking 3 readings, we will go for calculations. Simple calculations. Your manual guide calculations are a little difficult to understand. So I will give you a simple calculation. What is a simple calculation? Okay, if this is done, please make a last note that 3 trials are done for both KCl as well as the water sample with the same procedure. Over. Have you all understood this particular experiment? This will be given to the exam.
Ma'am, how much temperature should come, ma'am?
25 degree is the must. If your water is not giving you 25 degree temperature, you will take a calibrated reading. Like for example, I got 22.7. Okay, I got 22.7. So I went for 22 and 25, which is the calibrate for me. 23 was calibrated. Okay, in between 22 and 25. So I took 23 and that reading I have taken for calculation, calibrated it 105. Clear? The chart will be provided for you. Otherwise, you go for, if you are not getting or if you are getting 25, well and good, go for 25 only. Immediately write into 25. If you, I have, since I did not get, I took it as a calibrated reading. Okay, so same procedure is done for three times. After this, we are doing calculation. Very simple calculation you write. Same thing you write in your record also. Okay, calculation is constant micromole per centimeter is equal to constant micromoles per centimeter is equal to what conductivity did we get of water?
Zero point 221.
0.221.
221.
Good. 0.221 into what was the conductivity of the cell?
0.960.
Sorry, I didn't get you.
1.003, ma'am.
Of the cell, not KCl.
0.960.
0.960. 0.960 into your temperature. If you are putting 25 degrees Celsius directly, well then good put. Otherwise, since I have taken a calibrated reading, I am taking as 1.05. That is for 23. Okay? So when you multiply these three, you will get an answer that is millimoles or micromoles per centimeter. Multiply and tell me the answer first.
Ma'am, we'll have to convert the 25 degrees Celsius in Kelvin, no?
No conversion. No conversion. Directly we are doing.
This at the end, what have you written? After 0.960?
0.221 into 0.960 into 1.05.
Ma'am, 0.222768.
0.222768. This much of conductivity. Conductivity constant is provided by the particular water. Very easy experiment. Okay, done?
Ma'am, what is this 1.05?
That is a calibrated temperature value which I took because my temperature was not exactly 21. Sorry, it was not exactly 25. If your temperature is coming exactly 25, then mention 25 there. Mine was not 25, so I've taken it as a calibrated value for 23.
Ma'am, if you have the table for temperature calibration, can you share it on the group after the class?
Yeah, you can share it on the group.
Ma'am, I'm asking you if you can share it if you have it.
See, it is the same. You are doing free trials. Observation you want me to share.
No, the temperature calibration table from which we can see how. I just want to see
Yeah,
how we
that I will. I'll send.
read it.
I'll send it. I'll share it on the group.
Ma'am, might be answer 0.241.
Whose answer is 0.241?
For this calculation.
Together you are getting
41.
But somebody else
0.241.
said
0.241 is coming. Check it out, ma'am.
241.
Yes,
Is the
ma'am.
reading? Okay. Is it done till here? Is it done, students?
Yes, ma'am.
Okay. Now, what all you will be writing in the experiment? What all you are writing in the record? Please make a note of it. You will write one small introduction about conductivity. It is there in your manual guide. It's very big. Don't sit and write the complete thing and waste your time. I've already told you in the last classes also. Please read, cut short, whatever is important, write that only. So you will be writing introduction of conductivity, some small introduction you will be writing. Then you will be writing principle, procedure which I gave you, not your textbook manual guide procedure. Procedure which I gave you, apparatus or requirements you can copy from your manual guide, and the readings which I gave you. So we did 3 sets, tabulation for KCL and tabulation for your water sample. 3 times also, same reading was there. Make 2 columns. Sir, please mute yourself. 3 times also same reading I got. Make 2 columns. One is for KCl, conductivity of KCl, 1, 2, 3, one below the other. It was 1 all the 3 times. And conductivity of water, 1, 2, 3, same reading all the 3 times. And then do the calculation. This is your experiment. Please make it small and simple. Do not write everything of your manual guide. We are not performing with such a big thing. It's a very simple experiment. We are just performing. Because you have to come directly for exam letter for the performance. Alright? Yes or no? Please tell.
Yes, ma'am.
That
Yes,
Ma'am,
energy
can
of
you
first
repeat
of
the
class is
tabular
not
column?
there.
The tabular column, can you repeat?
Tabular columns, 2 tabular columns. One is for KCl, 3 trials. Second is for water, 3 trials. Readings are the same. Calculations, what we did now. That's all. And at the last, you will write the result. The conductivity of the given sample is dash.
Okay. Okay, ma'am.
Alright. So this is your first experiment. Please keep it simple. Do not elaborate and write anything extra. Moving to the
Ma'am, I
second
have one
one. Shall we
question.
move to the second one now?
Yes, ma'am, I have one question.
Yes.
Ma'am, can you again explain how, like, what is the relation between adjusting the range? How do we do that when the reading is coming so and so?
See, if it is going beyond your 31, you have to place your knob between 2 to 20. Now 2 to 20 means it's not a very big reading, just 3 readings they have given. Turn the knob between 2 to 20 and leave. When you're turning the knob between, like how you turn your gas stove knobs. Okay? So if you turn between 2 to 20, you will get normal reading. Depends on water I mentioned. What water I have taken here is your tap water. So the reading should be very low. Clear? It is a very normal, simple water. If we are going to any pond or lake water, then the reading should be high. First of all, we are not giving you the material from any pond or lake. We are giving you normal tap water. So your reading should be definitely between 2 to 20. So when you turn your knob between 2 to 20, you will get the reading on your digital reading board.
Okay, and ma'am, if the reading is below 31, then
Below?
31.
That's what I said. It should go below 31. So if the knob is turned to 200, definitely it will not go below 31. That is why you have to adjust the knob.
Ma'am, didn't get you. You were saying when the reading is coming beyond 31, you turn the knob to 2 to 20.
That will not happen, dear, but because it's a normal tap water, it will not take place like that. This was tested 3 times, and 3 times also same reading I have got. So I am telling you, better adjust the knob initially between 2 to 200, 2 to 20 only. Don't adjust beyond. It will not go beyond. So I was told, since it is normal tap water and your water is going 31, so my knob was not adjusted initially. So they told adjust the knob and see. When it is adjusted, I've got 22 something.
Okay.
Understood,
Okay,
ma'am.
got
Thank
it.
you.
Shall we go on to the next one? Determination of hardness of water sample.
Yes, ma'am.
Take the composition properly here. Okay, these are experiments done, and then we are giving you. I told last class, if it is offline, you will be coming here and doing. Experiments done, composition is done. So please make a note of it. Write the heading determination of hardness of water sample. Determination of hardness of water sample. So what exactly is the hardness of water sample? It is generally the ability of water to react with soaps. Okay? How, you must have studied about the hardness of soap and detergents in your previous classes if you have studied or if you have taught somewhere. Okay, we have the hydrophobic and hydrophilic sides in the soap water molecule, and in the soap molecule, the hydrophobic are not getting attracted, hydrophilic are attracted. That is a very different concept. Okay, missile is what they study in soaps and detergents. Now here we are determining why is the water hard and how much it is hard. Now the water will be hard because of its dissolved salts in it. Okay, water of different places is different, and different salts will be present. Then there some are very toxic salts also. Because of the presence of salts in that particular water is hard. So you are determining the hardness. Now hardness is of two types. One is temporary hardness, the other is permanent hardness. Okay, hardness of water is of two types. One is temporary hardness and the other is permanent hardness. What is this temporary hardness? If the carbonate salts of magnesium and calcium are present in water, that is magnesium carbonate, calcium carbonate, if those salts are there in water, that water or that type of water is called as temporary hard water. Why is it called as temporary hard water? Is because you can remove the hardness by only boiling. Did you get it?
Yes, ma'am.
Yes, ma'am.
Okay, I'm repeating again. Two types of hardness of water are there. One is temporary hardness, the other is permanent hardness. Temporary hardness is that type of water where you'll be having calcium and magnesium carbonates being dissolved in water. And that is called temporary because you can remove the hardness only by boiling water. Whereas permanent hardness of water will have chloride salts in it, nitrate salts in it, along with carbonate salts. Here I'm mentioning here temporary hardness will have only carbonates of calcium and magnesium can be removed by, can you all see? By boiling, whereas permanent hardness will be having chloride salts, nitrate salts, and carbonate salts of calcium and magnesium. So these many salts will be present and it cannot be removed by, and sulfates. Sulfates. That is calcium sulfate, magnesium sulfate, calcium nitrate, magnesium. These type of salts will be there in the water, which cannot be removed by boiling. Henceforth, a proper titration method should be performed to remove the hardness. Okay, this is the difference between permanent hardness and temporary hardness. Is it clear?
Yes, ma'am.
Okay. Now, what are we doing for this to remove? As I mentioned just now, we are taking the titration method. For titration method, what are required? Your apparatus are required. Please write down the apparatus. You require conical flask of 250 ml. You require beakers, probably 100 ml beakers or 200 ml beakers. You require burette. Since it is a volumetric method, titration is there, burette is needed. Burette of 25 ml. Then We require pipette. To pipette out the sample, we require pipette. Pipette of 1 ml is enough. We require funnel. And we require measuring cylinder. And then we require reagents. Okay, reagents has to be prepared. You have to prepare the reagents. Now for the preparation of reagents, what are the chemicals required? Please make a note of it fast. You have to be quick. So the first is sodium salt of EDTA. Sodium salt of EDTA.
Ma'am, sodium salt of?
EDTA. Full form of EDTA is ethylene full form of EDTA is ethylene diamine ethylene diamine tetraacetic acid. Okay, so sodium salt of EDTA means sodium salt of ethylene diamine tetraacetic acid. That is the first salt you require. Next we require erichrome black tea. Erichrome black tea. It is a salt given and the short form of the salt is EBT. Erichrome black tea. The short form is EBT. Then you have to have magnesium chloride salt, MgCl2 salt, magnesium chloride. Then 95% of alcohol, that is C2H5OH, ethyl alcohol. C2 means it is ethyl. Okay, so 95% of ethyl alcohol you require. Then you require ammonia buffer. Ammonia buffer will be given. If it is not given, we have to prepare. Okay, mention ammonia buffer. For the preparation, I'll give you the composition. Then deionized water. What is deionized water? It is your, yes, somebody's raised the hand. Lakshmi. Any doubt?
Yes, ma'am.
Yes, ask.
Is it available in the manual, ma'am? The preparation of these reagents?
No, I am giving you.
Okay.
All right. And then water is required. That is a distilled water. Okay, that is required. Because last class when I told you follow the reagent preparation, you went wrong. Then we had to re-prepare one reagent of potassium iodide crystals. So please take this exact composition. That is why I have done all this. For the preparation of EDTA, the reagent preparation, exact composition should be done, should be taken. Okay, 4 grams of sodium salt, 4 grams of sodium salt, 0.1 gram of magnesium chloride, Very little, okay, and then 800 ml of water. Take it as 1 gram of magnesium chloride, sorry. 4 grams of sodium salt, 1 gram of magnesium chloride, and 800 ml of water. Dissolve, this is your EDTA. Okay, next, for erythrome black tea, preparation for erythrome black tea. 0.4 grams of black tea you have to take from the bottle. 4.5 grams of 4.5 grams of hydrochloric salt. That is also there in the chemical, so HCl. So hydrochloric salt, 4.5 grams of HCl. 95% of alcohol, which should be 100 ml. That is 100 ml of 95% of alcohol. C2H5OH, ethyl alcohol. Ethanol. I'm repeating, 0.4 grams of EBT, 4.5 grams of HCl, 100 ml of 95% of alcohol. That is your EBT. You will be having one blue color solution, dark blue color solution, black tea type, dark blue, black color solution. So 2 conical flasks are prepared now. One is your EDTA, the other is your EBT. Then ammonia buffer. If ammonia buffer is given, well and good. If it is not given, what you have to do? Please speak quick and mention. 16.9 grams of ammonium chloride. 16.9 grams of ammonium chloride. 143 ml of ammonium hydroxide. 143 ml of ammonium hydroxide. Then for that add 1.25 grams of magnesium chloride salt. Magnesium salt of EDTA, not magnesium chloride, magnesium salt of EDTA. So you are taking 16.9 grams of ammonium chloride, 145 ml of ammonium hydroxide, then 1.25 grams of magnesium of EDTA, and you will dissolve in 250 ml of distilled water, 250 ml of distilled water. In that you will take only 10 ml out. You are taking only 10 ml out, and that 10 ml should again be dissolved in 100 ml of water. If you come here for preparation, please do not make mistake. I'm again repeating, you are dissolving all those three things, ammonium chloride, ammonium hydroxide, and EDTA of magnesium in 250 ml of water, distilled water. You will take 10 ml out of it. The 10 ml should again be dissolved in 100 ml of water. That is your ammonium buffer.
100 ml of distilled water?
Yeah, distilled water. Alright. Now coming to the procedure. In your burette, you will be taking EDTA of sodium, the solution what you had made. So burette will be having EDTA solution. Mentioned burette will be having EDTA. Very simple titration this is. Once you take EDTA in your burette, in your conical flask, 100 ml of sample you will take. What sample you will take?
Water.
Water.
Water sample. Good. We didn't mention water sample anywhere. So you know it is water sample. So water sample is 100 ml you are taking. For example, tap water, you will be taking 100 ml in your conical flask. To that water sample, you will add 1 ml of ammonia buffer, only 1 ml of ammonia buffer. Okay. And then you will drop 5 to 6 drops of EBT. In the conical flask, I'm repeating again, you will have water, you will have ammonia buffer, which is 1 ml, 100 ml of water, 1 ml of ammonia buffer, and 5 to 6 drops of EBT. The moment you add EBT, the color of the water changes to wine red color. Or you can mention purple color, wine red, okay? Wine red color will be there. So that is the color of your conical flask, solution present in the conical flask. End point, please mention from purple to blue. End point is from purple to blue, that is from wine red to blue color. Until then you are titrating against EDTA. Okay?
Ma'am, repeat once again, ma'am.
End point is from purple to blue.
From the starting, conical flask, how much we have to take that one?
Conical flask, you will be having 100 ml of water, 1 ml of ammonium buffer, and 5 to 6 drops of EBT. 5 to 6 drops of EBT. The moment you add, your solution will be purplish in color or wine red in color, that shades, purple wine red shade, or magenta pink, that shade will be the color of the solution. Now that particular conical flask has to be titrated against EDTA. When you are titrating it, the color changes from purple color to blue color. So the moment you see blue color, you have to stop your titration. Volumetric titration, all of you know. Understood?
Yes, ma'am.
Yes, ma'am.
Then what you are doing is, you will take 3 readings, 3 trials. That is initial, final, and consumed. 3 trials, 3 columns you have to make with 3 rows. Initial reading of your EDTA, final reading of your EDTA, consumed. How will you calculate consumed?
Final minus initial.
Final minus initial, very good. So 3 readings, go for a concordant value, take it for calculation. Okay? So if you have your manual guides, open your manual guides and see, there they have mentioned one blank. Okay, in observation, if you can see, volume of EDTA consumed by the sample, that is what is the concordant value, and EDTA consumed for blank. Now you will get confused what exactly is blank. Blank is nothing but your distilled water. One parallel reading will take. Okay? So like how you are doing for water sample, likewise you will be doing for distilled water also. So the concordant value for distilled water, concordant value for, yes, somebody is raised a hand. Please tell me what. All right. Okay, so for distilled water and for tap water, you are doing same procedure. Only you are changing the water. And take the concurrent value and do the calculations. Okay, will you do that?
Yes, ma'am.
All right. Now you have to only write your records and come. But when you come here, you should study that and come. So this is what I'm supposed to do. So by this, your second experiment is over. So hardness of water sample only you are writing in the result. You will not write anything for blank. Okay. Then coming to the third one, that is determination of total solid and total dissolved solids in water.
Do we need to write precautions or all?
No, not required.
Determination of
Determination of solids, determination of total solids and total dissolved solids in water. Okay, so here this is again a very easy experiment, but without the apparatus we cannot do this. Okay, so put this as a demo experiment. Third experiment is a demo experiment. Okay, on the board also, if I can explain you, it's a little difficult. You will not understand it because you require the measurements. We will be having a suction pump here, creating a pressure and all that. So this third experiment will be a demo experiment. So if you remember last what we did 12 experiments and there are some demo and some performing experiments. So this is one of the demo experiments. Apparatus will be kept, you have to write. Okay? Did you get that? All right.
Yes.
So your first experiment is performing. Your second experiment is performing. Your fourth experiment is performing because it is already performed in the last class. Sunday we performed here in college. It was told in one of the theory classes also, BOD, how BOD and what all reagents required. Same Winkler's reagent only we are using. Exactly the same procedure. And I don't think so I have to repeat the same procedure again.
Madam, we did not get the readings of BOD.
yes, ma'am.
But they said they will be sending. When I was shouting that take the readings and go, all of you were telling we'll take from the group. They will send it on the group.
Ma'am, we have sent it. Is there in the
They are
group.
not
Picture is there
sending,
in the
ma'am.
group.
See, please, whoever is having the readings, please send the readings to others. Put it on the group. Sudhishna is telling it is already sent. So the ones who have not checked, please check. Okay, last class when I was telling please take the readings and go, everybody were in a hurry to go. And then you people said we'll share it on the group. So the same readings, the same procedure is for oxygen demand and biochemical oxygen demand. Clear?
Ma'am, we use the same reading for experiment number 4 and 5.
Same reading you can use. Now, what is the difference in biochemical oxygen demand? That is in the fifth experiment is that we'll be taking D1 minus D2. What is D1 is? D1 is nothing but your initial demand of oxygen of sample. So one is we are taking the sample initially before incubation, and D2 is we are D2 is after incubation. Okay. Now what is this incubation? How did we do? Last class we took some plant samples, we weighed them before drying, after drying. You remember? Do you remember?
Yes, ma'am. Yes.
Okay, like that only. Here for oxygen demand, what we do is we will use oven, okay, and we will first, without incubating, we will take the reading. That same procedure will follow, and we'll take the demand of oxygen. And after incubating the sample, we are redoing. That is the only different thing we are doing here. Yeah, slightly different. Same procedure, a little lengthy experiment than your experiment 4, because you have to incubate the sample and then take the reading. All right. Okay.
Yes,
So since this is a lengthy experiment, I will try and put this experiment also in a demo, because that particular day you cannot take the reading. You have to wait for hours of incubation. So experiment number 5 will also go in demo. So out of 5 experiments, experiment number 3 and experiment number 5. 5, I am still not sure, I will ask, because we have already done it. 3 is definitely going for demo. Yes, Sudhisha?
4 is not demo, right, ma'am?
4 is not demo. 1, 2 and 4 are not demo. 3 is a definite demo. 5, we have done it. One step, a little more you have to do, that is you have to incubate. That's all. Nothing different is there. You are taking a reading before incubation, like for bio.
We can't hear you.
You did control, you did. Here what?
Ma'am, your voice is not clear.
Okay, I'm repeating again. 4th experiment is oxygen demand experiment, where we are using Winkler's reagent and we are checking the oxygen demand. That is what we did in the last class. Same experiment it is. Whereas 5th experiment is also the same experiment, same procedure, but here we are incubating water. Okay? Then in the 4th experiment, we did not incubate water. Instead, we had taken controlled light and dark bottles. Here, we are taking water before incubation and water after incubation. 3 bottles we took. Here, only 1 bottle before incubation, after incubation. That's all. Okay? So,
Ma'am, in
please write
4th
this.
experiment, ma'am, in 4th experiment, we kept it for incubation, ma'am, light and dark. For some time, for 1 or 2 hours, we kept.
That's what, light and dark. 3 different bottles you did. And you did for very less time.
Yeah, correct.
Probably 1 hour only you did.
Yes, ma'am, yes.
But this is not the 1 hour. Okay, it takes time. Incubation period. You are keeping it in oven. Okay.
Okay,
So
ma'am, understood. Thank you.
please write these 5 experiments in your record. When you are coming to college, you have to submit. Especially this batch, I guess you have to submit 3 records. All right.
Ma'am, do we have to write all the 17 experiments of MEL12?
No, that's what. Like how we did for the last record, I do the same for this record also, because we are running short of time. Right, the 5 experiments are done. I told in the initial of the class only. 4th and 5th experiment are the same. 3rd experiment is a demo. You cannot do that experiment, so please write in your record. We are not considering it. 1st and 2nd experiment is a performing experiment. I have explained you the complete procedure with the reading. Now coming to 6th experiment.
Okay, one thing you tell me, students, as we are running short of time, can you write all 17 in your recorded sum?
No, ma'am. No,
No,
ma'am.
ma'am.
Please.
No, ma'am.
So shall we keep 12 experiments for this record also?
Yes, ma'am. Yes, ma'am. Well, ma'am.
Okay, 12 experiments for this record also we are keeping out of 70.
Ma'am,
Alright?
it will be 10, ma'am. Make it 10.
Ma'am, can you make less?
You want
Ma'am,
less?
yes, ma'am.
Okay. So out of 2 performing experiments we did. I'll give you one more 2 performing experiments I'll give you, okay? So that is acidity of water and alkalinity of water. These are very easy. So these 2 experiments we'll do it in the afternoon session. Alright? So experiment number 7, 8 and 9. We'll try doing it in afternoon session. Shall I keep 10 experiments?
Okay.
Yeah, 10 is.
Yes, ma'am.
Okay,
10
ma'am.
is enough?
Yes, ma'am.
So
Yes,
this particular manual guide, they are keeping 10 experiments. Alright, in that I'll keep 5 as performance, 5 as demo.
Okay, thank you, ma'am.
Okay? So whatever performing is left out, I'll do in the afternoon. Like I'll be doing 6th and 7th session. 6th and
Okay,
somebody is
ma'am.
not doing it. Chandana, I get to yourself.
Ma'am, can you explain like how the exam will be, ma'am? Like little bit about how it is going to be.
Do not worry about the exam. Paper should be set by us only. I will only set the paper. I will keep you in my mind and I will set you the paper. Bharati, please mute yourself.
Okay, thank you, ma'am. When do we have to come to college, ma'am, again for the offline sessions?
See, that I don't know. Okay? If we finish 3 also tomorrow, then you can come next week.
Ma'am, what about experiment number 6? Ma'am, experiment number 6.
That's what. That also I'll try putting it into demo.
Okay,
What
ma'am.
is easy
Okay.
for you, I'll put those for performing.
Okay, ma'am. Okay. Okay. Thank you, ma'am.
Okay? Like first is easy, second
Yeah.
is very easy, and then acidity and alkalinity is also easy. So these will go in performing experiments.
Okay, ma'am.
Okay? So meet
Yes,
you in
ma'am.
the afternoon session. Class is from 1:30.
Okay, ma'am.
Okay? Alright. Take care. Bye-bye. 1:30, please log into the same meeting.
Thank you,
Thank you,
ma'am.
ma'am. Thank you so much.
Thank you, ma'am.
Thank you, ma'am. Thank you.
Ma'am, 1:30, ma'am.
Ma'am left, ma'am left.
Today, hello guys. If today we can complete 12, na, then tomorrow we can pick up with maybe 13. We'll ask madam to do it that also.
Yes, sir.
Sir, 10,
Yes, sir. Yes, sir.
Okay, na, that is better. So out
sir,
of 10 experiments, 5 performing, 5 demo. We'll make it that 10, and the students will write that 10. So tomorrow we'll make it maybe 13, so that this whole week we can write it and we can attend for practical exams on 20 and 21st.
Sure, sir. Sure.
okay, sir.
Some are
Only
not
10 only.
10 only. So we'll ask madam or 13 also 10, 5 demo I recommend that, so that we'll complete it by tomorrow all the practical, especially for the consecutive.
Yes, sir. Correct.
Okay, so to afternoon what we ask madam is right now till now there are till now we completed 6 experiments out of 3 demo and 3 practical. So afternoon again we'll confirm with 7, 8, 9 performing with demo, so that we'll get that clear 10 practical, which are 5 water, 5 demo, water, 5 experiment. Okay, already some we got it, so that we'll finish it off all. That is 5 demo, 5 experiment today itself. So tomorrow we'll ask madam to pick up with the ME30. Okay, that also request madam for demo, 5 demo, 5 practical or 3 demo, like that. By tomorrow we'll pick up all the practicals and we'll write
Yes,
all
ma'am.
the We'll write these cards and we'll attend class practical on Saturday. Okay. Thank you. Anything can anybody can share it? Please share.
If anyone having this one readings of experiment 7.
Experiment 7 of MEV 11, madam. MEV 11 you are asking?
Share it in the group, sir. They're getting that readings.
MEV 11, I think it is there in the 2021 group, madam. MEV 11 is there. Otherwise, experiment 7
not there, sir.
Madam. Amrita, please share that. But there is a BOD and COD, but they have given only BOD data. BOD. So we know only the BOD data. Amrita, if she is there in line, could you please share in our 2021 group? Amrita.
I think Amruta has left.
After left. Raghavendra, you can also share it that one, okay?
Yeah, I will ask to Amruta, okay?
And please share that one experiment 7 that we have only BOD values only, Raghavendra. That
Okay,
day they
sir.
did not perform COD. Actually, they did something and they did not get the values. That values also like us manipulated values. So that only will put it what we do. That's on this thing because that solutions or buffers and everything they took different values. That is the reason they did not get the proper readings and everything. Madam,
yes, okay. I will talk to Amruta, okay?
Try to. So Raman, please share that one group so that we all can write down. Okay.
Sure.
So tomorrow is we'll get ready for MEV 13. So
yes, sir, we are ready.
20 students will request madam to finish MEV 13 also by tomorrow itself. Okay, na?
The ma'am also said that 13 students are not performing.
Not performing, but at least what are demo, what are experiments, something like that, like a 12, na? In 12 also we are not performing, Raghavendra, na?
Yes.
So same way, at least we can write something, na? So that we'll finish it by tomorrow. We can write it for 4-5 days. We'll complete all 3 records and we'll go to class.
Yes,
okay?
sir. In condition, coming Saturday we should write an exam.
Yes. We have exam coming Saturday and Sunday. Saturday we have 11 and Sunday we have 12 and 13.
Yes, sir, yes. That will be fine.
That will be fine. And also I put in the group, in our group also, per project also, no, these things we try to finish it by June 15 or something like that. Shall we keep a deadline so that we ask madam for this one Viva in online or offline in one day, no, we can complete it any one Saturday or Sunday.
Yes, sir.
Instead of Raghavendra, instead of waiting till July 31st, all exams will be completed by June end only, no?
Yes, sir. Yes.
Viva can complete by June end. We'll get certificates and everything by July end, so that you can join.
For we people, Jan 2021 people, we have already completed all the papers, written papers.
Yeah, that's what.
Raghavendra, for that only sir is saying.
If we can complete Viva, submission of project, okay, and completion of Viva by June 15th or 20th of June, something like that, everything can be completed by June end only. That's what I'm planning.
Yes, sure, yes.
At least 10 students like you and Sar is there, and myself and Gartaridi sir, and there are 2-3 Amruta. So many people are ready to submit.
Yes, sir.
If 10-15 students submit the practical project, then we can request madam to conduct Viva.
Correct, sir. Correct. That we can do. Yes, sir.
Okay, na?
You have to request the ma'am.
Okay, what exactly 2021 approximately there are 17-18 students are there, Raghavendra.
Yeah,
out of 17-18, I think so there are 10-15 students, 15 up to 15 students may come for exam. If whoever attended the 13 exam, MEV 13, we request all the 13 students to submit their project also by June 15th, something like that. Because see 2021, that means this month we have 10 days, next month also we have 15 days. So almost we will get it 3 or 4 weeks time. If we can submit by maximum by June 15th or June 20th, we'll request madam to conduct at the June last week Viva by online or offline, whatever the way possible. Okay, so that we'll get rid of our batch by all these practicals, projects, everything. Okay, that is my intention. So if everybody started Neeti and who are all there, at least we 15 students should be very cautious.
Yes, sir. Correct. You are saying correctly, sir. We'll try our best to finish it up everything by June.
And one more request also, if anybody have facing problem with project and everything, please go to any college having PG post graduation like botany, zoology, chemistry, physics, or any other science, microbiology, genetics, any thing. Bring from one copy, one project from that library, just cut, paste, and do it that thing. This is IGNO. Okay, this is they are not that much enough. Just this is only a kind of the experiment which how they can perform and everything. It's not like that MPhil thesis or PhD thesis and everything. Just we need to follow some steps, and of course don't break up some practical these things. With a maximum thesis project is maximum 50 pages. If we can give for introduction, then review of literature, objectives, and everything, itself will cover 20 pages. So don't pick much tough practical projects and everything. Very simple one which is available online, or which you can able to perform, which you can able to know some.